Hello everyone, welcome to the video solution for Edexcel IAL Mathematics. This is C12 Summer 2018 Part 3. Let's start. Question number 11. The curve C has equation y is equal to f of x. F dash of x is equal to 5x squared plus 4 over 2 root x minus 5. It is given that the point P4, 14 lies on C. Find f of x, writing each term in a simplified form. So we are given f dash of x, that means this is derivative, and they are asking us to find the function f of x. So from derivative to the given function we need to integrate it. So we are going to integrate this function and then let's see what can be done. So basically f of x is integral of 5x squared plus 4 over 2 root x minus 5 dx. And because we have some variable in denominator here in the first term, so we cannot integrate. First we need to simplify. So I'm sending this root x in numerator, so I can rewrite this as 5 by 2. This root x goes up and this x squared, so 2 minus half, so x to the power this is 3 by 2 and plus 4 divided by 2 is 2, and this x root x goes up, becomes x to the power minus half minus 5 as it is. This is dx, and now I can integrate these three terms easily. So 5 by 2 into, if you integrate x to the power 3 by 2, so 3 by 2 plus 1. Remember, for integration, if you have x to the power n dx, when you integrate this, you have x to the power n plus 1. You add 1 in the power and divide it with n plus 1. So similarly, I will do x to the power 3 by 2 plus 1. 3 by 2 plus 1 is going to give me 5 by 2 divided by 5 by 2 plus 2 to the power x minus half. So minus half plus 1. So x to the power half divided by half minus 5x, integral of minus 5 is minus 5x plus c. So this 5 by 2 and 5 by 2 gone, and this 2 goes up and multiply with this 2 becomes 4. So you can say that f of x is x to the power 5 by 2 plus 4x to the power half minus 5x plus c. So this is my function f of x, but it is not the answer because I still have c unknown and I need to figure out value of c. For this purpose, we are given that the curve C is passing through this point. So that means this is the value of x, and this 14 is f of x or f of 4. So you can say that if I replace x with the 4, so f of 4 should be 14. So I can say that 4 to the power 5 by 2 plus 4 into x to the power, not x, 4 to the power half minus 5 times of 4 plus c is equal to f of x or f of 4. F of 4 is 14. Now clearly you can simplify this equation, or you can solve this equation for c, and if you solve this for c will give you value of minus 6, and then resubstitute this value of c in my in this function. So finally your f of x with the obtained value of c, f of x is x to the power 5 by 2 plus 4x half minus 5x plus, not plus, but minus 6. This is your value of f of x. Find the equation of the tangent to C at the point P. Given you answer in the form of y equal to mx plus c, where m and c are constant. Okay, so we need to find the equation of the tangent. Tangent means tangent line. So remember, derivative, that means f dash of x is gradient of tangents. Gradient of tangents on the curve and at some point x, and the point which is given as p for 14. So again, if you see, we need, in order to find the equation of the tangent, that means we need a point y minus y1 is equal to m times of x minus x1. So this x1 and y1 is the point on the tangent. In this case, the point is P, the coordinate for 14. So this is x1, this is y1. So we have x1, y1, but we don't have the gradient. But the derivative is the gradient of the tangent line. So we just substitute x equal to 4 to figure out gradient of this particular tangent. So that means m is basically f dash of 4. So 5 times of 4 squared plus 4 divided by 2 root 4 minus 5. Once you figure out m, so value of m is 16. If you solve this, value of m will be 16. So now the equation of the tangent y minus y1, y1 is the coordinate of the point, in this case 14, is equal to m 16 times of x minus x1, x minus x1, the x coordinate of the point 4. Now you can simplify this equation, and you can rewrite this equation in the form of y equal to mx plus c. If you simplify and rearrange, so you have equation y is equal to 16x minus 50. This is the equation of the tangent line. Question number 12. In this question, solution based entirely on graphical and numerical methods are not acceptable. Okay, solution of quadratic trigonometric equation. So solve for 0 to 360 degree 5 sine of x plus 65 plus 2 is equal to 0. Okay, so in this trigonometric equation, we have given a sine function with some complex angle. The easiest way of these types of equation is we make this angle as simple as in a one variable. In order to do so, we assume x plus 65 with one variable. So I'm going to assume that let capital X is equal to x plus 65. It's your choice, you can choose any letter. So if you do that, then your equation transform into 5 sine of x plus 2 equal to 0. Now I can easily solve this equation for capital X. So sine x is equal to minus 2 by 5. That means capital X is sine inverse of minus 2 by 5. So it will give you x is equal to minus 23.57. So one decimal place, okay, so minus 23.6. So this is the value of capital X, and we need to figure out the rest of the angle in the interval 0 to 360 degree. So what do we do in this case? We ignore this negative sign, just ignore for a second, and consider the angle as x is equal to only 23.6, and then we have coordinates line, and then we have 4 lines just making these small. This is small angle 23.6 is just not exact like this. That means all these angles with the x-axis, this is 23.6, this angle is also 23.6, this angle is 23.6, and this one also 23.6. And after drawing or sketching these 4 angles, we need to select the coordinates. And how do we do that? We go for the actual equation from where we got this angle. So sine x is minus 2 by 5. If you see that sine is negative, sine should be negative, and we know that sine is negative in third and the fourth quadrant. So we ignore this first line and the second line. So my first solution is this angle. This is my first solution. That means 180 till here plus 23.6. So 180 plus 23.6. So my first angle, capital X, is 180 plus 23.6 will give me 203.6, comma, second answer is this. That means 360 minus 23.6. It will give me 336.4. So these are the two values, two angles for capital X. But capital X is the variable that I introduced. The original variable was capital X, so I need to replace this x with the small x. That means I need to subtract 65 from these angles. So meaning a small x should be 203.6 minus 65, meaning 203.6 minus 65, and then you can find the sum of these two. So you have 138.6, comma, and 336.45 minus 65 will give you 271.4. These are the two solutions for your first equation. Okay, so now let's talk about Part 2. Find for 0 to 2 pi all the solution of 12 sine square theta plus cos theta is equal to 6. So we have a quadratic, it's again a trigonometric equation, but we have a two different function, cos and sine. So first we need to transform this equation in any one of the function. The easiest way is to change this sign into cos. So the whole function would be cos. 12 sine square theta. Sine square theta is 1 minus cos square theta plus cos theta is equal to 6. If you rearrange this equation, so you have 12 cos square theta minus cos theta minus 6 is equal to 0. Clearly this is the quadratic equation. If you don't understand, you can replace this cos with some other variable. So let's say let y is equal to cos theta. If you do that, so you can write 12 y square minus y minus 6 equal to 0. Even you can assume some variable x equal to cos. So this equation will be 12x square minus 6 it doesn't matter. Now it is algebraic equation or a quadratic equation. You can factorize this. So you can, once if you factorize 12y square minus y minus 6 equal to 0, you have 3y plus 2 and 4y minus 3 equal to 0. From these two factors you can say that y is equal to minus 2 by 3 and y is equal to 3 by 4. So that means cos theta is minus 2/3 and cos theta is 3/4. From here theta is 2.30 because you need a 3 significant figures, so 2.30. And from here cos theta is 0.723. So we need to figure out rest of the angle in the interval of 0 to 2 pi for both situation. So because cos is negative, and we know that the cos remains negative in second and the third quadrant. So but this angle is greater than pi by 2. What I'm doing, in order to visualize the position of the angle, I am subtracting this angle from pi. So it's just for understanding, okay? There are some other method to do, but it's easy for me. What I'm doing, if your angle is greater than 90 degree, your obtained angle or your first angle is greater than 90 degree or greater than pi by 2 in this case, you subtract the obtained angle from 180 or pi. That means pi minus 2.3. So your answer will be 0.842. This is the angle we can sketch and we can visualize, or we can see rest of the angle. Because cos is negative, this sign is showing. So for cos remains negative in second and the third quadrant. So this is the angle 0.84, and the second angle is this 0.842. So my first solution is this angle. That means pi minus 0.842. So my first answer, theta, is 2.30, comma, my second answer is this, so pi plus 0.84. So pi plus 0.84 will give me 3.98. So these are the two answers from my first solution, and this angle is already less than 90 degree. So for this angle 0.723, the original equation cos theta is 3/4, which is positive. So I have a first quadrant and the fourth quadrant. This angle is 0.723 and this angle is also 0.723. So my first solution is starting from this axis. So my first solution for this is theta is equal to 0.723. My second solution is this angle, that means 2 pi minus 0.723. So my second solution is 5.56. So 5.56 radian. So overall, you can say that my all solutions for this equation is okay. So theta is equal to 0.723, comma 2.30, 3.98, and 5.56. These four are my solution. Question number 13. The point A 9 minus 13 lies on a circle C with the center, the origin, and the radius R. So if you have a circle and this circle is centered at the origin like this, so this is origin 0 0 and this is the radius. In this case, the general equation of the circle centered at origin is x square plus y square is equal to r square. So the point 9 minus 13 lies on the circle C with the center at the origin and the radius r. Find the exact value of r. Because this point lies on the circle, so it should satisfy the equation of the circle. So you just put these values of x and y in the equation, the general equation, to figure out value of r. And so how do we do that? Just replace x and y with these coordinates. So x square means 9 square plus minus 13 square is equal to r square. So r is 5√10. So 81 and 169, yes, of course. So 5√10. This is the radius. Find an equation of the circle C. Clear. So you have radius, so you can say that the equation of circle is x square plus y square is equal to r square. R square is 25 times 10, that means 250. 250. This is the equation of the circle. A straight line through point A has equation 2y plus 3x is equal to k, where k is a constant. Find the value of k. The straight line also passing through the same point A, 9 and minus 13. So this point also lies on this line. That means in order to find k, we just replace x and y again with these values. So you can say that 2 times of minus 13 plus 3 times of x means 9, is equal to k. So k is equal to 1. This is the value of k. The straight line cuts the circle again at the point B. Find the exact coordinate of the point B. So situation is this point A, which is 9 minus 13, that means 9 minus 13 is somewhere here. This is point A. And this line 2y plus 3x equal to k is passing through somewhere. I don't know. I just need to plot it again. So if suppose this is the line passing through like this. So this is the next point B, suppose, and that we need to figure out the coordinate of. So point B is the point of intersection of the line and the circle, and the point of intersection is found after solving simultaneously the equation of the two curves. In this case, equation of the line and equation of the circle. So equation of the circle is x square plus y square equal to 250. This is my equation number 1. And 2y plus 3x is equal to 1 as k equal to 1. This is my equation number 2. So I need to solve these two equations simultaneously to figure out the coordinate or the value of x and y. So I just need to use a substitution method because one is quadratic, the other one is linear. So from equation number 2, I am making y as a subject, so y is equal to 1 minus 3x divided by 2, and this is equation number 3. Substitute this equation value of y in equation number 1. So 1 implies that x squared plus y squared, 1 minus 3x upon 2 whole squared is equal to 250. And then you see that you have algebraic equation only in terms of x. So x squared plus, remember, don't forget to open this using completing square. So 1 minus 3x whole square, a minus b whole square. So you have x squared plus 1 minus 6x plus 9x squared divided by 4 minus 250 equal to 0. You take the LCM and simplify this equation. At the end you have 13x squared minus 6x minus 999 equal to 0. And then you can use the factorization method, which is quite difficult in this case because of the large number. So it's better to use a quadratic formula. So x is equal to minus b plus minus b squared minus 6 squared minus 4ac 13 minus 999 2a. If you solve this, you have value of x as 9 and minus 111 over 13. So 9 is the one value of x, which is the x coordinate of the point A, which is this. That means the second point B has x coordinate as minus 111 over 13. So you can substitute minus 111 over 13 in equation number 3 to figure out value of y. So just replace x in equation number 3 and solve for y. So y is equal to 1 minus 3 times of 111 over 13 divided by 2. So y is equal to 173 over 13. So coordinate of B would be minus 111 over 13 comma 173 over 13. So this point is in fact somewhere here. Okay, so this is the coordinate. Thank you very much. Hope you understand. Have a nice time.